Hi and welcome back. Today's episode is about extreme gradient boosting. We're going to use extreme gradient boosting for predicting house price for unit of area. In our case, we're going to use regression. Also, we're going to detect the outliers and eliminate the outliers for improving our model. Also, we're going to use feature engineering. What is feature engineering? How to create new variables. We're going to improve our model from previous videos and compare the performance of our model with extreme gradient boosting. Let's go. As we were talking in the previous video, we were going to predict the house price of unit area with some variables. In our case, transaction date, house age, distance to the nearest MRT station with each unit. Yes, you can see it here, the geographic coordinate, that means longitude and latitude, as well as number of convenience stores in the limit circle. You can see we have 6 variables for predicting one dependent variable. In the last video, we eliminate transaction date. Why? Because as we can see here, it had some weird format. As you can see it here, the date doesn't look like we used to use a date. So we are, in this video, we're going to include this variable date. Okay, and we're going to use feature engineering, how to transform this variable into a date format, and also how we can extract year, month, and date. For that, we're going to load our libraries. That means XGBoost, sklearn, and Pandas. Also, we have to read our dataset. We're going to use pandas.read.csv, as you can see it. And also, I let you the link for downloading this dataset I'm using right now. You can see it here in Archives, UCI. And we can see some of the first 5 observations: transaction date, house age, distance to the nearest MRT station, and so on. The idea is to predict house price of unit area using the regression with extreme gradient boosting. And we're going to compare the performance with our previous model where we didn't use this one here. But let's see how we can improve our model using feature engineering. How important is this? And then you can see we have 414 observations with 8 columns. And now let's go to the second part. Okay, here we are. Now the idea is we are going to change first the name of each of these variables because they're too long. As you can see, the format of these names are so not as we used to work with variables. So, and also we don't need this column here, number, so we drop it. For that, you say data.drop the column's name here and axis equal 1. Remember, the axis equal 1 means columns. See, if you are talking about the rows, we say axis equals 0. Okay, now for renaming columns with pandas in Python, we come here and say data.columns. So we're going to rename all the columns at the same time. So it's important to know how many columns we have in advance, because if not, we don't include all the columns here. So we're going to have some problem with the shape, all right? So we have date, this one, we change it just for date. House age, we eliminate the X2, X3, and so on. Distance to MRT, number of stores. House price of unit area. Okay, but now we're going to call it house price unit. We will know that it's going to be unit of area. Okay, not exactly the price of the house, but just unit area. Okay, now let's go to the big deal here, feature engineering. What is feature engineering? So feature engineering is about developing or creating new variables coming from other variables. In our case, we're going to use date, transaction date. Where this sale of the house took place, when, okay? And we're going to modify a little bit transaction date. As you can see, we can see the date is a float number. You can see the format here. It's a float number. That means that it is not the format date. And we can change this using the library datetime. As you can see it, from datetime, import datetime. And we come here and use PD to datetime. We're going to develop it here. And we take the column we want. and we say data date format, as you can see, year. Why? Because I'm going to try to extract that date here. We're going to change this number to year. Okay, that's what I'm trying to do. We're going to say, okay, this is year. This, as you can see here, is a year. Okay, and we're going to save it in a new column. It's a new column or new variable or new feature is daytime. And we're going to say, okay, from this column, daytime, please extract year. So you can see it here, say daytime index. You're going to give me only the year. Okay, and now we have two new variables, daytime and year. Okay, and we come here and we will see what is going on here. As you can see, when I convert my date into year, it's a 2012-101 because it's just detecting the 2012, of course. And okay, well, this is now a date for format date, and we're going to extract the year using .year, as you can see. It's important that all this is coming from Panda PD. Remember, daytime index into daytime. Not necessarily we are using this. And year, as you can see it. So now we are able to extract date and we take the year. But we can extract more information, right? We then extract the month. Something important here. Now, from this same variable date, as you can see, I'm going to tell something important here. Okay, the number to the right of the decimal point has to be month and day, and to the left of that decimal point should be the year. Okay, so I'm going to use that function apply. As you can see it here, is important. From this same feature here, date, I'm going to say, okay, for each of these observations, please, you're going to take it and you're going to give me only this part here. Okay, this part here. So you can see it, we're going to split. Where do we split it? With this TR. We're going to split into parts. First one is going to be for month, and then the other one is going to be for the year. However, we don't really need this year too, but we're splitting this into parts. Okay, and we will see the result. So you can see here, I was saying we split with a decimal point and not decimal point. We split and we have month now here, as you can see it, all that decimal points here, and year too. However, we don't really need this one, but it was part of the process. And now we have to convert this month in a real month, of course, because that's not a month. There's no month, decimal month. So what we have to do? We're gonna change first this to an integer, and also we have to multiply by 12. Why to 12? Because if we have 0.5, for example, that means that we are in the half of the year. That means it's going to be June. Okay, and as you can see it, we can change year to integer if we really want to use it, or we haven't done this process before. Okay, that's other process too. Okay, if you take it as an example, and month we're going to multiply by 12. That's what I say. Okay, and we can see what's happened. What happened here? Month now. Every time we multiply by 12, you see, it's November. November, what could be this one? Okay, June, and September. And the year now is an integer. Well, so we're going to choose between this one and this one, okay? No problem. We have two options. But what is going with this 0.004? Okay, because we had month, not exactly an integer, that means that we are including some day here. It's going to be November with other day. Some other day we have could be that second day of the month. Okay, this one is at the end of the month, at the end of June, for example, and so on. How can we convert that? Okay, let's see. Now we have month. We're gonna do the same process. We're gonna split this into parts, as you can see it here. Math.modf. We have to modify it, and we're gonna split in two different columns again: month and day. Okay, we can replace month by itself because we're gonna have 11 here, as you can see it. We're gonna transform this one into the same variable's name, and with day we split and we will see. Okay, now we have 0.004, 0.004, and so on. So you can see month now, because the process was to split a decimal or real number, we have now a real number. However, we have to change it to integer, and we can do it using as type integer. And what's going on with day? Well, you know that we have 30 days. Usually we have 30 days per month, so we're going to multiply it by 30. However, if you inspect your data, you will see that there are some information here with 0, like this one, for example. So there's no day 0, right? So that's why I have to add 1. So it's important to inspect your data. I'm just showing you here 5 observations, but you can, remember, use n equal 10, for example. You do that. You can see more data, more observations. Okay, and this is the process. That column multiplied by 30 and add 1 number to avoid this day 0, right? We don't have day 0. And also change this data type to integer. Okay, and now we can see what we got. We have extract from this weird format 3 different columns or 3 new features. Of course, we don't need date, time, and we don't need year 2. Okay, and that's what we're going to do. Now that we have transformed and create new variables, we're going to eliminate date. I don't need this weird format, and the other variables I told you. And now, variable selection. Using again drop is date, time, year 2, drop them please, axis equal 1, and we finally have 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 8 variables for explaining house price unit. And that's what we're going to do. And as I mentioned in the intro, we have to detect 2 outliers. Maybe that's a process, or that was a process we should do in the first episode to improve our model. Our model had that testing validation a terrible validation. It was a terrible performance. But what if we had done in the previous model, with the previous model? Okay, let's see how it is going to improve. We have here how to detect outliers. First of all, can you see the histogram? House price unit histogram directly with Pandas. Remember, there's an option for creating plots with Pandas, not necessarily with matplotlib. And we can see that there are some outliers here. About 100, there are some numbers that we can say that maybe there are so expensive houses that are beyond that normality. So we have to use this filter, as you can see it here. Detect all those observations with house price unit less than 90. Okay, and those are the variables we're going to use. So all those observations, please tell me which are the rows. Okay, this is true, true, true. And then, okay, those are the observations we want to, and save them back in data. We create a copy and we save it in data. Okay, that means we're going to eliminate these variables. As you can see, our histogram has changed. Now it looks more like a normal distribution. Does it help? Yes, it helps because we can expect some values in this range. It is easy to calculate the probability to have a house price unit in certain range or intervals when the data behaves normal. Now we're going to select our variables and we're going to run the split training test. As you can see here, now we select which ones are the independent variables. We drop house price unit from data and we say X. In X, we have all our independent variables. And in Y, we're going to have only house price unit. That is going to be our target. And then we use trained test split from sklearn to use our train test data. As you can see, we have certain difference between the length of our training test. You say 309 observations and 104 for testing or validating our model. Remember that there is also an option here for telling Python how we want to select the proportion of each of them. Okay, let's see now our regression model. As I did before, I'm not gonna change nothing else but the default values for XGB regressor. I'm just gonna call it XGB regressor, and I create my model, and then I fit using X train and Y train. All these values here, as you can see, are my default values. Some of the most important I mentioned is learning rate, usually 0.3, some people prefer 0.2, max depth, how deep is gonna be my tree, 6 maximum. GP unit, if you have GPU, you can add the 0, for example. And also you can change number of estimators, 1000, 200 if you prefer to, and you can play with this to improve or to compare the performance of your model. Now let's see. Once we have fit our model, we call the plot importance to see how our feature engineering has changed our importance. We are going to compare it with the previous feature importance we had, where we didn't have month, for example. We didn't have month. Now we can see that the variable month we just create is more important than number of stores near the house. So that's good. That means that this variable we just create, it takes more importance in the regression tree than number of stores. Okay, and they in here, we have to do something with them because it's not look so important when we are creating that tree, or when XGB is creating that tree. Okay, now let's see the train performance. We use the function predict to predict using the data we use for creating the model. That means xtrain. We save it in pretrain. And now for regression, remember there are two important parameters to measure our performance. Those are R squared, that means the coefficient of determination, and the mean square error. Some people also use root mean square error, that means just only squaring the result of this, of course. And we use two functions, R2 square for nice scikit-learn and mean square error. So you can see it here. What it does mean? 0.996, which is almost perfect performance for the data, or using that data we create the model. That means it's predicting that X train, that means that data we use almost perfect. This means overfitting. Why? Because with the same data I create the model, when I predict is almost perfect, there must be something there. In this case we call it overfitting. Why? Because we're going to compare it with our test data, and we will see how distance of the performance are, how different the performance is in each case. As you can see too, mean square error, the MSE, is low, 0.54. That means that the square of these errors is small. It's super small, it's very small, and it's another sign of overfitting. And to confirm this, let's see how it went in that test performance. In way that we're doing the same. As you can see here, mean square error for that test is 44. It's super distant to this one, right? 0.54. Okay, as you can see, the errors here, the square errors, are way far away from that 0.54 for that train. Okay, but look at the coefficient of determination. We have improved our model. We have improved the coefficient of determination of our model for that validation test. What it does mean R squared, remember, is how much can I explain of the variance of my data using my regressor, in this case, extreme gradient boosting. That means that we have a 74% of variance explained by XGB. And how was, or what was the performance of our previous model? Okay, it was 36, 0.36. That means that we have doubled our performance just using feature engineering. Okay, how important is feature engineering? As you can see it, the mean square error too, it was 111. So that means that we reduce it less than the half. That's a big step. However, we still have a problem here with the overfitting, as you can see. It's okay. We have improved our model with new data. Remember that that test data have not been used for creating the model. So it's a big step. Feature engineering is so good. Okay, as you can see, house spread unit, the real one, versus the predicted ones. It follows a almost perfect line. Okay, that means that we have a good model. However, we can still improve our model. And that's what we're going to do in the next episode. In the next episode, we're going to select more variables. We'll use techniques to select the best variables for creating our model. And also, in next videos, we're going to talk about grid search. How to select the best parameters for our model. We're going to use something called hyperparameter tuning. And, well, any comment, any idea or recommendation, please, it's welcome. And thank you, and see you next time.